Figure out our conductor size for a motor that we have the horsepower and voltage given to us. If we do not have the horsepower or the voltage given to us and we only have one of those things, there's not enough information to find your answer, and there should be an answer in the questions that says not enough information or something like that, and that will be your answer. Next, we go into our Holy Bible, and we go to table 430.248. We do not use the table before this that says direct current motors. We're not dealing with DC. It doesn't say anything about DC, we're using AC. It also doesn't say anything about single phase or three phase, so we're going to be doing single phase. Okay? So what do we have? We have a quarter horsepower and we have 120 volts. We're going to go to our horsepower. I'm going to focus this. We're going to go quarter horsepower. We're going to find our voltage. I'm going to explain this. 5.8. But that says 115 volts. Our question said 120 volts. Don't even think about it. They're trying to trick you. If you see 115 volts, and if you see 230 volts, scratch it. Don't think about it. Just use 120 and use 240, and you will get the correct answer. They do all sorts of things to keep you on your toes. Okay, so we got our answer. Quarter horsepower, 120 volts, 5.8. Okay? And now, because heating, air conditioning, and lighting, other than dwelling units and motors, are considered continuous duty, and we add 25%. So obviously, this is a motor. So motors, we add 25%. Okay, so to add 25% to something, we're just going to get the whole number 1, and then 25% added on top of that whole number, and we're going to multiply that by what we have. So that adds 25% onto this. Okay? So that's our answer. 7.25 amps. Next, we open our code book again. We go to table 310.16. This is a very commonly used table. You should know this in the back of your head. You should know 310.16 is for ampacities of insulated conductor. What is ampacity? Ampacity is the maximum amount of amps that you can put on a wire without it getting too hot. If it gets too hot, it'll melt the insulation and it won't be insulated anymore. Basically, the reason for this is so that the insulation on the outside of your wire doesn't get damaged, and so it stays good. Okay, other than that, let's find our answer. We have 7.25 amps. Okay, you see where I highlighted yellow? I go up to where it would be 100, or I go up to under 100. Anything under 100, I highlight in yellow in the 60-degree column. Anything under 100 amps, you're going to use the 60-degree column. I would do this in your notes too. And then I did this a different color, starting from 100 amps. Okay? And that shows us that if you have anything past 100 amps, you're going to use your 75-degree column. Copper, because our question doesn't mention copper, aluminum, does not mention any type of metal. If it does not mention any type of metal, you always use copper. Okay? Use your copper table. There's only one problem with this table here. Where is 7.5? 7.25. There's just blank spaces. Okay? Well, it's good to know that if you're sizing wire for a house, and if you have something that has 7.25 amps, you're going to be using 14 gauge wire. Okay? That's the smallest electricians are typically going to use for line voltage. And right here it shows you that if you have 15 amps or less, you're going to be using this. And obviously this doesn't mean 20 amps or less, this means in between 20 amps or anything above your 15. Okay, so this is just 15 and below. So if anything below 15, you're going to use 14 gauge wire. That's why I chose this question as the first one. I thought it was a really good one. And there's our answer. 14 gauge AW